Question 5, we have this recurrence relations. Tn plus 1 is a quarter of Tn. T1 is 144, so to get T2, we write down n is equal to 1, not T, n is equal to 1, T2 is equal to a quarter, n is 1, a quarter of T1, and a quarter of 144 is equal to 36. When n is equal to 2, we get T3, which is a quarter of T2, which is a quarter of 36, which is equal to 9. So you can see we're just dividing by 4 each time, so we'll be able to write it out now. 144, 36, 9, and then 9 divided by 4 is 2.25. Find s to infinity, the sum of the entire series. So we know that s to infinity is a over 1 minus r. Write down what a is, write down what r is. A is 144, and r is the common ratio, which is a quarter. We're dividing by 4 each time. So 144 divided by 1 minus a quarter will be 3/4. And 144 divided by 3/4 is 192, I think. 192. Question 5. Question 6, we have x1 0.2, and just have r instead of n now. So x2 is when r is equal to 1, you can see. So when r is 1, we get x1 by 2 minus 4 times x1. So x1 is 0.2. 0.2, can we do it without a calculator? 2 minus 4 by 0.2. So we get 0.2 by 2 minus 0.8, which is 0.2 by 1.2. And 0.2 by 1.2 is a fifth of 1.2, which is 0.24. Or 2 12s are 24, 2 decimals 0.24. So that's x2. x3 is x2. We write down r is equal to 2 for x3 by twice minus 4 times x2. So x2 is 0.24 by 2 minus 4 times 0.24, which is 0.24 by 2 minus 4 24s are 0.96. So we get 0.24 by 1.04, and this is equal to 0.2496. Question 6. Question 7, we have this recurring relationship. We have u1 given is 0 and u2 is 1. So we want to get u3, so n is going to be equal to 2. And it says find u4, so let's find u3 first. u3 is when n is equal to 2. So therefore we get u3 is equal to u2 plus the square root of u2 times, this is a multiply symbol here, times u1, because n is 2, so u2, and then the whole thing is over 2. So this is equal to u2, which is 1, plus the square root of u2 by u1. Well, anything by 0 is 0, so that's 0 over 2. So that's just equal to 1 over 2. And then to get u4, n would be 3. So u4 is equal to u3 plus the square root of u3 times u2 all over 2. u3 we got to be a half, so a half on top, a half plus the square root of u3 by u2, which is a half times 1, square root of a half over 2. And this comes out as a quarter plus a half times the square root of a half, which is the form they wanted in here. I think that's good enough. We don't have to simplify it any further. So it's number 7, and then number 8. We have this sequence. We're told that U1 is a half, and we're asked to find the sum of the first 24, so S24 required here. So U2, what's going to happen here? U2 is going to be when n is 1, we'll give us U2, so U2 is when n is equal to 1. We get 1 plus U1 by U2 is equal to 1 minus U1. So 1 plus U1 is 3 over 2, 1 plus a half. So 3 over 2 times U2 is equal to 1 minus a half, which is 1 over 2. So if I multiply both sides by 2 and divide by 3, I get U2 is equal to 1 over 3. So let's look at U4. U4. Sorry, that's U2. U3 next. U3 next. U3 is when n is equal to 2. So we're going to get 1 plus U2 times U3 is equal to 1 minus U2. That's putting 2 in for n, 2 in for n, 2 in for n. So 1 plus U2 is 4 over 3, 1 plus a third, times U3 is equal to 1 minus a third. 1 minus a third is 2 over 3. Multiplying both sides by 3, we'll cancel the 3's obviously. And dividing by 4, I get U3 is equal to 2 over 4, which is 1 over 2. Now you could double check here. It looks like it's recurring. You could double check. I'm pretty sure that it does. It starts as 1 over 2, then goes 1 over 3, then goes back to 1 over 2. And if we start again, we're going to have to get 1 over 3 again, obviously. And the sum of the first 24 terms means we'd have 12 of these guys and 12 of those guys. So 12 by 1 over 2 is 6, plus 12 times 1 over 3, which is 4, is equal to 10. Just take your time with these, they're not that hard.